When we square root or cube root and do things like that, we end up with these sometimes irrational numbers. Okay, when we don't have perfect squares, for example, square root 5, we end up with an irrational number. And this number is not a fraction, but it is a number. We want to know where are these numbers on the number line. Okay, when we work out the decimal value of this, it's kind of easy to see because decimal values, it's easy to put decimals on a number line. So we get square root 5 is 2.236 ... But how can we find it exactly on the number line? Because there's no end to this decimal. Okay, 2.236 ... There's no end to this decimal, and we don't know exactly where that decimal ends on the number line. So to do this, we have to find, if we want to know exactly where this square root 5 is, we can do it geometrically. And we can do it in this way. We can use Pythagoras. We can find this length of 2 on the number line, and we're going to use a coordinate system here. So it's 2 and 1. Okay, so if we use Pythagoras, we end up with square root 5 along the hypotenuse. And so now we've generated the exact length here in our picture. And that length there, if we just kind of rotate it down, I'm going to take that point and now rotate it down onto the number line. Okay, it ends up right about there. And that point then is square root 5. That would be exactly square root 5. Okay, and that exists on our number line. So this decimal approximation is nice, but we can actually construct an exact length of square root 5 using Pythagoras here. So this is something that is useful to know. There is an activity at the end here online that you should try that will give us this idea of constructing exact value lengths. So some of the key points in this lesson today, and this is a really important point, these key points are important in this unit. Powers and roots are opposite operations of each other. They undo each other. Okay, that's a very important concept in math. A very straightforward concept, but it's very important to remember that every operation has an opposite. The other thing is, it's important to understand that powers and roots are not times and divide. Okay, so squares, square roots, they're not the same as times divide. Okay, although we can do repeated multiplication to get powers, we never say that repeated addition is the same as times. So we don't want to ever say that repeated multiplication is the same as powers. And the math behind them will be slightly different. So we have to be careful not to mix up our times math with our power math, because they will be different and they behave differently. So a couple of things to check. Do you understand the difference between exact value and approximate value? So that's something that we're going to start moving towards as we do grade 10 math, grade 11 and 12. We don't really want decimal values. Okay? We want the exact value is in a square root. So for example, square root 5 is an exact value. An approximate value would be, for square root 5 is 2.23 ... That decimal value is an approximate value. We do not want to have these. Okay? These are only useful to answer like word problems or something like that, measurement problems. So whole number radical value would be example 5. The exact value, the whole number radical value, is going to be something like this, square root 25. Okay, and that gives us, we would leave that as 5. If we have square root 24, we cannot square root this, so we just keep this as square root 24. And if we were to do an approximate, this is exact value, so this is exact. Square root 24 is an exact number. If I square root 24, I get a decimal value of approximately 4.89897 9, 4, 8, 6, dot, 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 dot. I can give as many decimals as I want. This is still an approximation because there is no end to this decimal. Exact, this is what we want. Okay, approximate values, although they exist, we don't want to rely on these anymore. These are only good for, measurement problems or answering word problems. So the last thing I want you to do is work on the CK12 assessment. And this will be showing how we can use Pythagoras theorem and roots to find exact value numbers on a number line.